here again, Joseph Jr. Welcome to Science and the Fourth Dimension. I'm always the ordinary teacher. Specialty is physics, mathematics, maths and physics, any other is fine with me. I teach the Cambridge and White class at the International School of Excellence here at Painesville, Liberia, Painesville City here in Liberia. It's a continuation work now on types of numbers. We've done the first part, this is the part, types of numbers. So we'll go further and see what we have to learn today. Now we're talking about what now, rational and irrational numbers. Rational and irrational. What makes it, in fact, the word rational came from the word ratio. Any number that can be written what now as a common fraction is what? It's a rational number. See, all those things you are seeing there now, they are subsets of rational number. Rational numbers are those numbers that can be expressed as a fraction of two integers, where the numerator is an integer and the denominator is also what now? A non-zero integer. Take note, a non-zero integer. Here are some examples of what now, rational numbers. You cannot be divided by what now? By negative value. 0.6 can be converted to common fraction. 7, I've told you before, any number that doesn't have a denominator, the denominator is 1. So 7 is a rational number, because 7 is 7 over 1. Take note of that. All whole numbers are rational numbers. Because any number that doesn't have a denominator, the denominator is 1. These are sets of what now? Of rational numbers. I have integers, I have whole numbers, I have what now? I have rational numbers, more or less. So let's talk about irrational numbers. Like the name is already what now? Know that a number that is not natural, rational is what now? Irrational. If you cannot write this as what? As a whole fraction of the whole number of another whole number, or integer of another integer, is what now? Is irrational number. Okay? So this will help you to guide you to know irrational numbers. This explanation there, you can pause and read through. Right? You have those examples. Do you know examples from here? Right? Irrational numbers. A decimal that is not repeat, a decimal that is not terminate, a number that is not a perfect square. It's the square of the number that is not a perfect square, right? It's an irrational number. We already said that irrational numbers are numbers that cannot be expressed as a single fraction or ratio of two integers. Also, their decimal representation are non-repeating and non-terminating. If you write them as decimal, you get non-repeating decimals and non-terminating decimals. These are a few examples of irrational numbers. You can read from there. Pi is actually the ratio of circumference over diameter. If you divide diameter of circle by circumference by diameter, you get that. The Euler's number, the square root of non-square numbers, cube root of non-cube numbers, and then the golden ratio. All of these values will give you what now? Irrational numbers. Let's go further and see. Right? Real numbers. Always remember to pause and then go over this thing so that you can master it. Real numbers are made of rational numbers or what now? Irrational numbers. The set of real numbers is a combination of rational and irrational numbers. If you put rational numbers and irrational numbers together, you get what now? Real numbers. Real numbers. Is that okay? Okay. You just take your time and then what now? Check the diagram. Like I said, you can pause and do what it needs to do. Imaginary numbers. Okay? Imaginary numbers are a mathematical concept that extends the real numbers by introducing imaginary units, denoted by what now? Small letter I. The imaginary unit is defined as the square root of -1. The set of imaginary numbers is expressed as multiples of this I. In general, an imaginary number can be written as bi, where b is what now? A real number. Others are what now? Examples. You can take your time and go through them. Imaginary numbers, they are not real. Because I can say that they do not exist. Right? So that's the definition for imaginary number. A complex number has two parts. Any number that has a real part and an imaginary part is called what now? A complex number. This is a combination of real numbers and what now? Imaginary numbers. They are written in the form a plus what now? bi. A and b are real numbers. The real part a and the imaginary part is bi. Together make up what now? The complex number. For example, 3 plus 2i is a complex number. The real part is 3, the imaginary part is 2i. 5i is a purely imaginary number because it does not have what now? A real part. I'm sure you get the difference. Okay? So here are some exercises for you to go through to be sure you've understood the concept so far. Use the figure to give a detailed summary of all that you have learned. Just try and explain everything that you have learned so far. And then you be able to tell from here whether or not you understood. You can go back and repeat everything again. Is that right? I'll see you in the next class. Thank you.